Table of contents. About the author. About the technical reviewer. About the contributors. Acknowledgements. Preface. Chapter 1. Introduction to Persistent Memory Programming. A high-level example program. What's different? The performance difference. Program complexity. How does libpmemkv work? What's next? Summary. Chapter 2. Persistent Memory Architecture. Persistent memory characteristics. Platform support for persistent memory. Cache hierarchy. Power fail protected domains. The need for flushing, ordering, and fencing. Data visibility. Intel machine instructions for persistent memory. Detecting platform capabilities. Application startup and recovery. What's next? Summary. Chapter 3. Operating system support for persistent memory. Operating system support for memory and storage. Persistent memory as block storage. Persistent memory-aware file systems. Memory-mapped files. Persistent memory direct access, DAX. Summary. Chapter 4. Fundamental concepts of persistent memory programming. What's different? Atomic updates. Transactions. Atomicity. Consistency. Isolation. Durability. Flushing is not transactional. Start time responsibilities. Tuning for hardware configurations. Summary. Chapter 5. Introducing the Persistent Memory Development Kit. Background. Choosing the right semantics. Volatile libraries. libmem_kind. libvmem_cache. libvmem. Persistent libraries. libpmem. libpmem_obj. libpmem_objcpp. libpmemkv. libpmemlog. libpmemblock. Tools and command utilities. pmempool. pmemcheck. pmreorder. Summary. Chapter 6. libpmem. Low-level persistent memory support. Using the library. Mapping a file. Copying to persistent memory. Separating the flush steps. Summary. Chapter 7. libpmem_obj. A native transactional object store. What is libpmem_obj? Why not malloc? Grouping operations. Memory pools. Creating memory pools. Pool object pointer. POP. And the root object. Opening and reading from memory pools. Memory pool sets. Concatenated pool sets. Replica pool sets. Managing memory pools and pool sets. Typed object identifiers. TOIDs. Allocating memory. Persisting data. Atomic operations. Reserve. Publish API transactional API optional flags. Persisting data summary. Guarantees of libpmem_obj's APIs. Managing library behavior. Debugging and error handling. Summary. Chapter 8. libpmem_objcpp. The adaptable language, C++ and persistent memory. Introduction. Metaprogramming to the rescue. Persistent pointers. Transactions. Snapshotting. Allocating. C++ standard limitations. An object's lifetime. Trivial types. Object layout. Pointers. Limitations summary. Persistence simplified. The ecosystem. Persistent containers. Examples of persistent containers. Summary. Chapter 9. pmemkv. A persistent in-memory key value store. pmemkv architecture. A phonebook example. Bringing persistent memory closer to the cloud. Summary. Chapter 10. Volatile use of persistent memory. Introduction. Background. Memory allocation. How it works. Supported kinds of memory. The memkind API, kind management API, heap management API, kind configuration management. Additional memkind code examples. C++ allocator for pmemkind. pmem::allocator methods. Nested containers. C++ examples. Using the pmem::allocator. Creating a vector of strings. Expanding volatile memory using persistent memory. libvmemcache. An efficient volatile key value cache for large capacity persistent memory. libvmemcache overview. libvmemcache design. Using libvmemcache. Summary. Chapter 11. Designing data structures for persistent memory. contiguous data structures and fragmentation, internal and external fragmentation, atomicity and consistency, selective persistence, example data structures, summary. Chapter 12, Debugging Persistent Memory Applications. PMEM check for Valgrind. Stack Overflow example, Memory Leak example, Intel Inspector, Persistence Inspector. Stack Overflow example, Memory Leak example, Common Persistent Memory Programming Problems. Non-persistent stores, stores not added into a transaction. Memory added to two different transactions. Memory overwrites, unnecessary flushes, out-of-order writes, summary. Chapter 13, Enabling Persistence Using a Real-World Application. The database example, different persistent memory enablement approaches. Developing a persistent memory-aware MariaDB storage engine. Understanding the storage layer. Creating a storage engine class. Summary. Chapter 14, Concurrency and Persistent Memory. Transactions and multithreading, mutexes on persistent memory, atomic operations and persistent memory, lock-free algorithms and persistent memory, concurrent data structures for persistent memory, concurrent ordered map, concurrent hash map, summary. Chapter 15, Profiling and Performance. Introduction, Performance Analysis Concepts, Compute Bound versus Memory Bound, Memory Latency versus Memory Capacity, Read versus Write Performance, Memory Access Patterns, I/O Storage Bound Workloads, Determining the Suitability of Workloads for Persistent Memory, Volatile Use Cases requiring persistence, Performance Analysis of Workloads using Persistent Memory, Characterizing the Workload, Memory Bandwidth and Latency, Persistent Memory Read-Write Ratio, Working Set Size and Memory Footprint, Non-Uniform Memory Architecture, NUMA, Behavior, Optimizing the Software for Persistent Memory, Summary. Chapter 16, PMDK Internals, Important Algorithms and Data Structures. A Pool of Persistent Memory, High-Level Architecture Overview, The Uncertainty of Memory Mapping, Persistent Memory Object Identifier, Persistent Thread Local Storage, Using Lanes, Ensuring Power Fail Atomicity, Redo and Undo Logging, Transaction Redo Logging, Transaction Undo Logging, libpmem obj Unified Logging, Persistent Allocations, the interface of a transactional persistent allocator, Persistent Memory Heap Management, Allocator Design for Persistent Memory, ACID Transactions, Efficient Low-Level Persistent Transactions, Lazy Reinitialization of Variables, Storing the Volatile State on Persistent Memory. Summary. Chapter 17, Reliability, Availability, and Serviceability, RAS. Dealing with uncorrectable errors, consumed uncorrectable error handling, unconsumed uncorrectable error handling, clearing uncorrectable errors, device health, ACPI defined health functions, _NCH_NBS, vendor-specific device health, _DSMIS, ACPI NFIT health event notification, unsafe, dirty shutdown, application utilization of data loss count, DLC. Summary. Chapter 18, Remote Persistent Memory. RDMA Networking Protocols. Goals of the initial Remote Persistent Memory Architecture. Guaranteeing remote persistence. General Purpose Remote Replication Method. Appliance Remote Replication Method. General Software Architecture. LibrePMEM Architecture and its use in replication. Configuring remote replication using pool sets. Performance considerations. Remote replication error handling. Say hello to the replicated world. Summary. Chapter 19, Advanced Topics. Non-Uniform Memory Access, NOMA. No MACTL Linux Utility. NDCTL Linux Utility. Intel Memory Latency Checker Utility. No MA-STAT Utility. Intel vTune Profiler, Platform Profiler. IPMCTL Utility. BIOS Tuning Options. Automatic No-MA Balancing. Using volume managers with persistent memory. The mmap, map_sync flag. Summary. Appendix A. How to install NDCTL and DAX CTL on Linux. Prerequisites. Installing NDCTL and DAX/CTL using the Linux distribution package repository. Searching for packages within a package repository. Installing NDCTL and DAX/CTL from the package repository. Appendix B. How to install the Persistent Memory Development Kit, PMDK. PMDK prerequisites. Installing PMDK using the Linux distribution package repository. Package naming convention. Searching for packages within a package repository. Installing PMDK libraries from the package repository. Installing PMDK on Microsoft Windows. Appendix C. How to install IPMCTL on Linux and Windows. IPMCTL Linux prerequisites. libzafic. IPMCTL Linux packages. IPMCTL for Microsoft Windows. Using IPMCTL. Appendix D. Java for persistent memory. Volatile use of persistent memory. Heap allocation on alternative memory devices. Persistent collections for Java, PCJ. Using PCJ in Java applications. Low-level persistent library, LLPL. Using LLPL in Java applications. Summary. Appendix E. The future of remote persistent memory replication. Glossary. Index.